Hello, good evening, everyone. This is Dr. Nilesh Ugemuge from Anand Nikatan College, Anandvan, Varora. And really, I am thankful to BARTI for inviting me to deliver a session on NET for physical sciences. And again, I am thankful to Mr. Rajiv Gandhi sir for giving me an opportunity and facilitating these particular classes. So, friends, this particular as just I thought to share the syllabus in my very first lecture. Not only share the syllabus, but want to highlight some issues related to any of the subject. How do we think about the subject? So, always what we are doing, we are just whenever we are preparing for any of the examination, then we are only just moving throughout the pages of the book, like we are preparing like a university examination, but any of the competitive examination is not like that. So when we are dealing with competitive examinations, so what we need to do, we have to work thoroughly for any of the syllabus or any of the topic rather than syllabus, I'm saying. So if we are talking about quantum mechanics, then the understanding of the quantum. Hello, good evening. Uh, so I welcome you all to the session for quantum mechanics. And again, here I'm going to deal with the syllabus of physical sciences for NET and SET examination. And thank you, Bharti, for giving me an opportunity. And again, in special, I just thanks to Mr. Rajiv Gandhi sir for facilitating this particular session. So, friends, when we are dealing with any of the topic from physics, as we know, everybody knows physics is like a tough subject. But if we have good understanding of the physics, then there is no subject which is like interesting like physics. And that is why whenever we are preparing for any of the competitive examinations, we have to prepare the strategy, okay, how to deal with that particular subject. So I'll be just trying to share with you some of the aspects, or we call it the basic aspects. So how to think about any of the subject. So when we are talking about quantum mechanics, so what should be arises in your mind first? सो ऑलवेज क्वेश्चन अराइजेस कि मैं ये सब्जेक्ट क्यों पढ़ रहा हूँ, है ना? तो सबसे पहला क्वेश्चन आना चाहिए कि ये सब्जेक्ट मैं क्यों पढ़ रहा हूँ, ये सब्जेक्ट का क्या इंपॉर्टेंस है, फिजिक्स में क्या इंपॉर्टेंस है, इस सब्जेक्ट का अगर अपन साइंटिफिक कम्युनिटी के लिए क्या इंपॉर्टेंस है, ये चीजें अगर अपने ध्यान में आती है, इफ वी आर जस्ट ट्राइंग टू अंडरस्टैंड दिस पर्टिकुलर कॉजेस, then definitely will create the interest or will develop the interest into this kind of the subject, else really difficult. So, in this context, I would like to share something about quantum mechanics. Why this quantum mechanics emerges? So, I hope you must be knowing about that. But still, I am just striving to share something. So, earlier to quantum mechanics, we know there were or still there is a existence of classical physics. है ना? पहले भी क्लासिकल फिजिक्स था, आज भी क्लासिकल फिजिक्स है. ऐसा नहीं हुआ कि 1900 में जब अराउंड 1900 when there was a evolution or when there was a introduction of the quantum mechanics into the scientific community, then there the classical physics should have absolute, but that doesn't happens. Why this happens, or why not this kind of the things happens? That is again the interesting question for everyone. So friends, why quantum mechanics introduced? Just let me share some story behind that. So what happened? People were just trying to study some of the microparticles. Like as we know, if we are talking about the atom, so even though in atom there is a nucleus, and again we know if we are talking about nuclear physics, there are number of particles inside the nucleus. So friends, so in that way means we are not dealing with only atom, means atom. Again, we are going inside to atom, and we will be thinking about proton, neutron, electron, and even though I said some of the particles which are present in nucleus, so they are smaller in comparison with the neutron, proton, and electron also. So the question arises: if we want to study the behavior of the electron, motion of the electron, like a means if we want to know the kinetics of the electron, then how do we study? So earlier to quantum mechanics there was a physics, or still there is a physics we called as the classical mechanics, and it is well developed mechanics. There is a sound theoretical base to the classical mechanics, and somewhat we called classical mechanics as a Newtonian mechanics. So what base they have? They have the fundamental equations, some of the, like as we know, the laws of motion given by the Newton, and again the that laws was elaborated by some principles of the classical mechanics. So but that, which means that, so it is well established physics. But again the question arises. So, friends, when scientists try to deal with some of the, as I said, kinematics, some of the motion-related problem with the microparticle, then they were unable to apply the concept of classical mechanics, and that's why there were need, or there were need to develop new kind of the physics. And again, because of that, there was an emergence of quantum mechanics. And again, as we know, quantum mechanics was developed. So the basic contribution in quantum mechanics has given by several scientists, from the Einstein to a Planck's, and again, as we know, de Broglie, Schrodinger, then Heisenberg. So friends, they thought like that. They have given some theories, they have given some proof with respect to some of the experiments. And then because of their hard work, as we know, now we have the quantum mechanics. And still now after quantum mechanics, we are thinking for number of theories, like a chaos theories, or like again some new kind of the physics we are thinking. So why and how it happens? Only it happens only because of the development of thorough quantum mechanics. And even though still somewhere we can see some inadequacy we find in quantum mechanics, so to explain that, or again sometimes to prove that, also some people are striving to work on quantum mechanics as well. Even though we know recently some Nobel prize was awarded for matter wave, then gravitational wave. And then again, if we talk about these all kinds of the phenomena, then we can come to know, so really there is a importance of quantum mechanics. क्वांटम मैकेनिक्स के बिना ये सब फिनोमिनन अपन एक्सप्लेन नहीं कर पाते हैं. सो फ्रेंड्स, सो तो इमेजिन करना पड़ेगा अपने को कि क्वांटम मैकेनिक्स मुझे पढ़ना क्यों है, या क्वांटम मैकेनिक्स को मुझे कैसे समझना है. So that is what. So if I elaborate, so if you think the equation in quantum mechanics, one of the fundamental equation in quantum mechanics is E is equal to h nu. So now you can see, whenever we want to explain the concept of energy, then we require the frequency. But again, as we know, energy is directly proportional to frequency. This equation shows. But the problem is that, so just to show this particular equation, we require some constant. Because if there is no constant, then the existence of equation has so many problems, as everybody knows. So, friends, that problem can be resolved by one of the prominent scientists, and who wrote his thesis, doctoral thesis, and again that problem was resolved by the Planck's constant. And as you may be knowing, E is equal to h nu. So that is the fundamental equation which can explain about the energy in quantum mechanics. Again, we know the again Einstein has given the equation E is equal to mc square. So how we can convert the mass into energy, and again how the speed of light is required to convert that. So and again abundant amount of energy can be generated from any of the substance, and again as you may be knowing that kind of the phenomenon we can explain or we can apply to the apply for making some of the, like as you may be knowing, some disaster happened in second world war like a atom bomb and all. So, friends, these kind of the concepts are really essential. Likewise, there are some concepts, as we know in quantum mechanics. Some other scientist has also given like concepts like, as you may be knowing, de Broglie's hypothesis, or we called as a wave particle duality. So that is the first topic of your this particular syllabus. So how do we think about de Broglie's hypothesis? De Broglie's hypothesis is just like lambda is equal to h by p. Now you can see how this equation is beautiful, and how many problems and so many problems can be solved by this particular equation. So here you can see lambda is what? So if we are talking about lambda, lambda is the wavelength. So if we are talking about wavelength, which means that here there is a wave nature. And if we talk about lambda is equal to yes, you can see h by p. So means simply if we are just trying to talk about lambda h by p, h means yeah, or yes, you can see pp is what now? P is the characteristics of any of the material particle. As we know, p is the momentum, p is equal to mv, which means that here there is a mass, here there is a wave nature. So what does it gives? So simply we know with the help of this equation we can understand if there is a dominance of particle nature, then wave nature cannot be dominated. So it is inversely proportional to each other, and that is why if we look towards the electromagnetic spectrum, and as we know electromagnetic spectrum from where it starts, like a radio waves, like m is microwave, then infrared, then visible, then like ultraviolet, x-rays, and the gamma radiations. And if we are talking about this particular electromagnetic spectrum, then we know if we are talking about the wavelength, so then towards the radio waves, as we know, we are getting the means wave nature is more, whereas if we are moving towards the gamma radiation, then we can see the particle nature is more. And there is one region we called as a visible region, where we can have the chances of getting the both wave nature as well as the particle nature. And then if we try to explain this particular electromagnetic spectrum with the help of quantum mechanics, then we can see beautifully how this particular de Broglie's hypothesis or the wave particle duality can be existed. So that is why, means this is what kind of the understanding we must have. Because if we talk about the gamma radiations, then we know the how strong it is, how much energy can be deliberated by that. Then but instead of that, if we talk about the radio waves, then we know radio waves can be used for the mobile communication. Or even though with the help of this internet, now you are listening to me, why only it is because of the radio waves. So now you can see, and if we instead of radio waves, if we use the gamma radiations, then what will happen? So then you may be knowing how the tissues of the human being or any of the animals can be burned with the help of gamma radiations or the X-rays. As we know, sometimes you may think, sir, X-rays are always exposing to the human body to understand or to know the cracks and all like that. So whether it is like a harmful or not? Yes, true, it's a harmful, but it is always exposed for a fraction of second, not for a longer duration, to take the picture of the cracks of anyone's bone and all. So, friends, in that way, we have to think. So, which region is most important, or every region is important? But again, every region has its applications, and that application, if we try to understand with with the help of some quantum mechanics, then there is no subject like quantum mechanics. So, friends, that is why this particular we called as a wave particle duality was there. And again, you may be knowing. Then again, there was a question how to prove that. So always lambda is equal to, I said, h by p or h by mv. So but how to prove that? Then again there was one experiment. I'll just explain in next class also in detail. So that experiment was the Davison and Germer experiment. So in case of Davison and Germer experiment, you may be knowing how they were trying to understand or calculate the potential or calculate the wavelength of the like electron as well as the wavelength of any of the radiations, and then on the basis of that they can conclude by considering some assumptions. Yes. So if we calculate the wavelength, then that wavelength must be similar, and then finally they have proved this kind of the relationship can be existing, and that is what the wave particle duality. And then again there were so many theories after that, and that again we can say supports the wave particle duality. Likewise, this wave particle duality, again I told you there was a Compton effect. So there was a photoelectric effect. Photoelectric effect was the like you can see the first experiments who supports the quantum mechanics. And I want to ask you a basic question: who received the Nobel Prize for the photoelectric effect? So can anyone write in a chat? You can write in a chat. So yes, I'm giving you some time. You can write in a chat. I will see your YouTube channel. So just think and write in a chat. So who has secured the Nobel Prize for, yes, Nobel Prize for quantum mechanics? Yes, please. I'm waiting. I'm waiting for chat. A chat is open for you.
Prize for
Yes. Anyone can share. Tell me, Einstein secured Nobel Prize for which experiment? For what Einstein secured Nobel Prize? Nobody? Nobody is here? Yes? Okay, so let it be. You can, yes, you can think. I hope some people will go through this particular topic afterwards. So they may think, or they can think like that and write in a chat. So we'll go through it. So friends, but for your like kind information, sometimes or every time, most of the students of physics they are saying Einstein secured Nobel Prize for his famous equation is equal to mc square, but it's not true. Einstein secured the Nobel Prize for the photoelectric effect. And again that photoelectric effect gives, like as we know, the particle means the first incidence we can see incidence for the particle nature of the light. Because when we are talking about light, then light is having a dual nature, and then it's really difficult to understand and difficult to explain how light behaves as a wave as well as how light behaves as a particle. So, friends, there are some experiments like we know the some of the common phenomenon in physics. The phenomenon you may be knowing like interference, diffraction, polarization, and again there is other phenomenon in physics. What this particular phenomenon tells us the entire story of the wave nature of the light, but they cannot explain the particle nature of the light. So if you want to explain the particle nature of the light, then we have to move towards the quantum mechanics. And again, if we go through quantum mechanics, then definitely we can understand the duality of the or dual nature of the light, and that is really important. And because of that, we can see so many experimentations, so many phenomena that are always explained by the scientist. And these phenomenon are, you can see, like if you talk about what, if you talk about the nanoparticles. Now everybody is trying to discuss, trying to see, trying to learn about the nanomaterials. So everybody is just fascinating by nanomaterials, and they are thinking how the nanomaterial can be understand. So my dear friends, let me tell you, if there is no quantum mechanics, then we cannot have the idea of the quantum mechanics, because we cannot see the nanoparticle by naked eyes, or like we are having the compound microscope or the other microscope which are available. So we can see only nano size by what? We can see only nano size by using a scanning electron microscopy, or the scanning tunneling electron microscopy we call as STEM, or by with the help of the atomic force microscopy. So friends, these are the phenomena we need to understand. Yes, everybody knows there is a term transmission electron microscopy, there is a term scanning tunneling electron microscopy. But what are the differences in these all kinds of the microscopy? How do we understand this microscopy, and which kind of the principle is involved into that particular kind of the microscopy? तो ये अगर जब तक अपन समझेंगे नहीं, तब तक कोई भी सब्जेक्ट का इंपॉर्टेंस समझने में बहुत दिक्कत होगी. So my dear friends, I request you to just try to go inside the subject and try to understand why this kind of the phenomena is happening, which part or which theory is responsible to occur this particular phenomena, and that is what the way to understand any of the subject. So I hope you can understand what I want to share with you. So friends, in that way, the Compton effect, then after that we know this like there were so many phenomena. So then Crompton effect है ना. So then there were after a photoelectric effect, there is a quantum like a Crompton effect, and Crompton effect again has given, you may be knowing, the difference between the wavelength, and then he has calculated the Compton shift, and again Compton shift gives us the scattering of light and all. So this kind of the phenomenon are really important, and this phenomenon develop the quantum mechanics, and that development is really beautiful. Again, one more thing you may be knowing about the black body radiation. So if we are trying to understand the spectrum of the black body radiation, then some anomaly is found in that particular spectrum. Then scientists thought how it happens. If we increase the temperature, why there is a change in wavelength. So that kind of the anomaly was explained only with the help of quantum mechanics, and that could not be explained with the help of classical mechanics. So friends, really this all basic phenomenon fascinated to number of scientists, and because of these all phenomenon, this particular subject was developed, and really means this particular subject is fascinated to every physicist. As a physicist, you can think, you can read more about this quantum mechanics. I will suggest some book, Quantum Mechanics by Aruldas is one of the good book which we can understand very easily, or Quantum Mechanics by Sheep, Quantum Mechanics by Merzberger, or the Quantum Mechanics by Ghatak and Loknathan. Even though quantum mechanics is explained in a very simple manner by the Arthur Bezer in his book. So friends, in that way we can understand quantum mechanics deeply, and then we can just try to explore the quantum mechanics, the phenomenon of quantum mechanics. So friends, then I will move to another equations. We know there is a Schrodinger equation, and Schrodinger has given the time dependent and time independent equations. So we are always thinking why these kind of the complicated equations are there, because really if we want to solve the problem in quantum mechanics, like one dimensional potential well, or the tunnel effect, or the hydrogen atom problem, then we require this set of equation. Without this set of equation, we cannot explain the phenomenon, any of the phenomena, and that is why the Schrodinger equation is the most important equations in terms of quantum mechanics. And Schrodinger has given two sets of equation. The first set of equation is time dependent equation, where there is a factor of time. Another one is a time independent equation, where there is no means this phenomenon cannot be studied with respect to time. So, and again, with the help of time independent equation, we can explain the phenomenon of one dimensional potential well. And as we know, if we are talking about one dimensional potential well, then we are finally reaching to the